So, hi, just a quick demonstration of a working prototype of a heating controller with weather compensation. It is finally here. So on front side there is a basic schematics with all measured temperatures here. So we are measuring flow temperature, source temperature. Source can be anything, can be a boiler, accumulation tank, or let's say heating for a building's heating station, anything. That's why I didn't draw any specific heat source, because it can be anything. And we are measuring outside temperature and room temperature. Yeah. Control for the actuator is 3-point, meaning we are opening them, closing it, or doing nothing. 3-point. There is a pump which is controlled with a relay. It can be pump or either you can control a boiler, and that is basically it. On the back side, this is currently 230 volts version, European version. On the right side you are connecting mains, line and neutral. You are connecting pipe, line and neutral, and you are connecting mixer. 3-point control. You have open, close and neutral. And on the left side you are connecting thermometers, which are digital Dallas type thermometers. All thermometers are connected in parallel. So you are putting 3 wires on each thermometer together and putting it into this terminal. The next terminal is for room thermostat, which can be used and doesn't have to be used. Next two are not connected, and the next two, which are missing terminal now, are for 0 to 10 volt analog control. This European version doesn't have 0 to 10 volt analog control. It is made only for US version, but even European version can have it. Even European version can have it. Okay, let's power it on and see how it works. So now it's connected to mains and to thermometers. Here are the thermometers, 4 of them. But of course, in reality, these are going to be thermometers which should be connected in parallel. Okay, let's power it on. Okay, this controller have 3 different modes in which he operates. Based on a selected mode, different numbers and different data is displayed on the LCD, and different data are set up. Now current mode is outside plus a room. So it means that the flow temperature is determined based on outside temperature, heating curve. This is the heating curve which is used to calculate the flow temperature based on outside temperatures. And in room correction, there is a sensor in the room which sends feedback to the controller and tells him how much the controller must change flow temperature to meet desired room temperature. Okay, so this is the, let's say, most complex mode, which uses 4 thermometers and all possible settings inside. This is the most complex mode. There is a outside sensor, there is a ongoing flow sensor, there is a source sensor, and there is a room temperature sensor which gives feedback about temperature. So let's say something about the display. By pushing the right button, info, data on display are changing because there wasn't enough space to put everything on this small display. Now we have a flow temperature. F means for flow temperature. Right next to it is desired flow temperature, which is now 14 only. Below it's room temperature and desired room temperature, and time and day in week. So now currently desired room temperature is 20.9, actual room temperature is 22.4, which means flow temperature must be lowered. And based on outside temperature, which is on next screen, the set point flow temperature is calculated, which is 14 degrees based on curves. And the valve is closing. You can see he's pulsing it to close because desired flow temperature is lower than actual flow temperature. So the valve is closing. Pushing info button, we are going to the next screen. Next screen says output temperature is 22 because all the sensors are on the same board, of course, or are the same. Outside temperature is 22 and this is too hot. I put in the settings that if the outside temperature is above 17, the system shuts down. That is why pump is not working and the mixer valve is closing full. But this value can also be changed, of course. And the source temperature is 22 degrees Celsius. So pushing the info button, we are going to the next screen. Next screen displays current mode of operation, which is outside plus room. And the next screen displays some data based on the actuator. So this is the actuator opening time. This is the PID parameters of the PID controller, which controls the actuator. And this is the selected motor for the actuator. Currently is 120 seconds for full opening. And the next screen, let's go on. The next screen is back on the first screen. So by pushing the info buttons, you are going around the screens. So first, second, third, fourth, first, second, third, fourth, first, second, third, fourth, first. So they are going around. Okay, let's demonstrate the settings. So setup 1 is on the left button, so push setup 1. We can choose setting the heating or setting the time. So we are setting the heating, for example. He asks us, do we want the default parameters? If we mess something up, we set to default. If we are not sure, but no, we are going to no. First, he asks us working mode. We can choose between outside plus room temperature, fixed temperature, so we are set only one value of the flow temperature based on the schedule. We have a heating schedule, we set the temperature and he just keeps the fixed temperature, the desired flow temperature. He's not looking at the outside temperature and he's not looking at the room temperature. And the next mode is outside plus thermostat. So he's got outside temperature and thermostat in the room, which is giving the contact if we want to heat. So the thermostat is only a contact which is normally open, and when it's open it is low temperature, which we set here. We set two temperature, we set low and high. if the thermostat is open, there is a low temperature. If the thermostat is closed, there is high temperature, which we set. So if the thermostat is closed, it means we need to heat. And if it's open, means lower temperature, we don't need to heat. So these are the three modes. And all the settings, all the display are based on the selected mode. So not all the modes needs all the parameters and all the data on the screen. All these data are based on the mode. So let's keep on with the outside plus room. So if we select this mode, next is actuator time, we set valve dead zone, we set proportional gain, integral gain, derivative gain, max source temperature, minimal source temperature, heating curve. As I said before, heating curve are on the diagram on the monitor. Next is outside temperature cutoff. When outside temperature is above this value, the pumps turns off and the valve closes because it's too hot to work. It don't need to work anymore. Room thermocorrection. So we have room thermometers, and for each degree of error between desired room and actual room, we are changing the calculated flow temperature by this percent. It will be in detail described in the manual. So this is just to get a basic idea. It is the percent how much we need to increase or decrease the flow temperature based on the error we have in a room. Let's go on, and these are all the data. So now, because I increased the outside cutoff temperature, it's 25 now. It's 25 out temperature, and actual out is 22, so it's not turned off and the pump is working. Okay, let's quickly go to setup 2. The valve is closing because the temperature is low. Let's go to the setup 2. Here we set up the thermometers. This is the order of thermometers. We said which thermometer is for flow, which thermometer is for source, for outside and for room. And the schedule, we are entering the heating schedule. Let's look at that. First, he asks us, do we want to default it? If we messed something up, we just set the values to default and have back to the factory settings or default, but here we say no. We have workday temperature, 19.9, let's say 20.1. Work night temperature. So we have working day day temperature, working day night temperature. Working day are Monday to Friday. Then we have weekend day temperature and weekend night temperature. And then we have the schedule. Working day temperature, start hours 10, start minutes 5. Night start temperature 22, start minutes 0. Weekend day starting hours 9, starting minutes 0. Weekend night starting hours 20, starting minutes 55. Okay. So based on the time, it's 12 hours 52 minutes. It's Sunday. Based on that setting, now the desired room temperature is 20.9 degrees, which we just set and confirmed. And this is something more than 2 degrees below required. And this and then this room correction is acting, and he is lowering the calculated flow temperature based on the outside temperature. It's only 14 and the valve is closing. So that's it, briefly. This is the prototype. I will do some minor corrections in the software. I will do some minor cosmetical corrections on this front panel design. It is okay, but I figured some things could be nicer. and please let me know what do you think about the software, what could be added, what should be deleted, what you want to see. You will have everything in details in a manual, so please wait for the manual. You will see everything there. When you are giving the suggestions, please keep in mind that the program, that the memory of the controller is almost full. Now I am at 93% of the memory, of the flash memory of the controller, so there isn't much room for adding features. It is almost full. There are many features. There are free working modes. There is a schedule, detailed schedule with 4 temperatures. There is a heating curves programmed into it. Heating curves which have a correction based on room temperature. There is a room temperature feedback controller built into it. There are limitations. There is a PID controller built into it. Many things are now inside, and I really hope you are going to like it. Okay, that's it for now. Thank you for watching, and tell me what you think. Bye.